Hello, and welcome to our lesson on documenting possible outcomes in probability. Today, we will explore important techniques that ensure we don't miss any potential outcomes when calculating probabilities, which is an essential skill for accurately solving probability problems. Following that, we'll apply these new techniques to various examples to solidify your understanding. So far, we have covered some foundational concepts, including using probability notation to represent different events, the addition law, and constructing sample spaces to display all possible outcomes of an event. With this solid groundwork, we are now ready to study how to document possible outcomes more systematically. This technique is crucial for accurately calculating probabilities and avoids the pitfall of missing any possibilities. For instance, imagine trying to find the probability of rolling a specific sum with 2 dice without visualizing all possible pairs of numbers. If we overlook even one pair, our calculations could be completely off. Therefore, mastering these methods will allow us to deal with probability problems more confidently and accurately. We'll begin with another thought experiment. Imagine I have 2 fair coins. I flip both and then look at the results. What is the probability that at least one of the coins lands on heads? To find this probability, we don't just rely on intuition. We use the formula for probability. In this formula, PE is the probability of the event E occurring, NE is the number of favorable outcomes for the event E, and NS is the total number of possible outcomes in the sample space S. In this experiment, our event E is at least one coin lands heads. It might initially seem that there are 3 outcomes: no heads, 1 head, and 2 heads. However, this approach is incorrect because it does not account for each distinct combination of the coin's outcomes. To accurately document all possible outcomes, we need to list each possible way the coins can land. Let's label the coins C1 and C2. One method of documenting the outcomes is using a 2-way table. First, create a table with the outcomes for each coin along the columns and rows. Then fill in the possible outcomes. Here's a 2-way table for our example. From this table, we can see that HH represents both coins landing heads. HT represents the first coin landing heads and the second coin landing tails. TH represents the first coin landing tails and the second coin landing heads. TT represents both coins landing tails. Now let's analyze the table. There are 4 possible outcomes, so we can write that the number of possible events in the sample space is 4. The event at least one coin lands heads includes the outcomes HH, HT, and TH. Thus, the number of favorable outcomes is 3. Using our formula for probability, which tells us that the probability of an event is the number of events favorable to an event divided by the number of possible events in the sample space, we get 3 divided by 4. Therefore, the probability of at least one coin landing heads is 0.75 or 75%. You can test this by flipping 2 coins multiple times and recording the results. Over enough trials, the results should converge to this theoretical probability. The essential lesson here is the importance of carefully documenting every possible outcome. If we categorized outcomes incorrectly or missed any, our probability calculation would be wrong. This thorough approach, using tools like 2-way tables, ensures accuracy. Now let's look at an example of rolling 2 dice. Consider the problem of finding the probability of rolling a specific sum with 2 6-sided dice. To avoid missing any possible outcomes, we can construct a probability table. First, we construct the sample space. Each die has 6 faces, so there are 36 possible outcomes. Create a grid with one die's outcomes along the top and the other die's outcomes along the side. Next, we fill in the table. Each cell in the grid represents a pair of outcomes, for example, rolling a 1 on the first die and a 2 on the second die. Write down the sums for each pair in the corresponding cells of the grid. Refer to the provided probability table diagram. Using the table, it is now easy to identify the desired outcomes. For example, to find the probability of rolling a sum of 7, identify all cells where the sum is 7. There are 6 such pairs. This can be used to calculate the probability of rolling a sum of 7 by calculating the probability is the desired number of outcomes divided by the total number of outcomes. So we get 6 divided by 36. This gives us an answer of 1/6. Finally, let's examine the probability of getting exactly 2 heads when tossing 3 coins. Again, we construct the sample space. Each coin has 2 possible outcomes, heads or tails, so there are 8 possible outcomes. List all possible outcomes in the sample space. We need outcomes with exactly 2 heads. There are 3 such outcomes, HHT, HTH, THH. This gives a probability of 3 out of 8. Now it's your turn to practice these techniques with more problems. In today's lesson, we explored the importance of meticulously documenting all possible outcomes when calculating probabilities. Using the example of flipping 2 coins, we demonstrated how to accurately list all possible outcomes using a two-way table. We also wrote down sample spaces for some of our examples and used that to calculate probabilities. By practicing these techniques, you'll enhance your ability to tackle probability problems with confidence and accuracy, ensuring that all possible outcomes are considered in your calculations.